All right, so I'm live here with an O'Reilly author, Addie, who recently wrote the book Scaling Machine Learning with Spark, correct?
Correct.
Correct, yeah, which is a really awesome book that I've had a chance to read over many different iterations. Maybe you can introduce yourself and say a little bit about your background and why you wrote the book.
Yeah, for sure. Well, first of all, thank you so much, Noah, for having me, and thank you so much for all the valuable feedback and insights while writing the book. I always say it takes a community to write a good book. So a little bit about myself. My background is in the machine learning and data space. I did a thesis on machine learning at scale, and I created multiple research projects for companies like IBM, Deutsche Telekom, and so on. And then at some point, I realized that data is really important. And so I moved all the way to the other side to build big data systems, big data infrastructure. And I really enjoyed that. And then this is when I discovered kind of like the difference between building a data system on-prem versus the cloud and the Hadoop world, and leveraging well, back in the days when I did my research, it was mostly Mahout that we used with Hadoop, and then moving into from from MapReduce into the Spark world was definitely a fun experience and a fun migration. Yeah, I guess all the way to today. So today I'm leading the DevX team as part of Treeverse. We're building LakeFS, is a data version control tool for your data lake. It's an open source. You're most welcome to come out and try it. It has also a lot of good use cases in the machine learning world, but maybe we'll talk about it a little bit later as we go.
Yeah, that's a great background for the book you wrote. It's obvious that you have deep expertise in reading the book. So if I would say, just to briefly talk about that, that what I liked about the way you wrote the book is that it not only covers the technology, and gets into Spark, but it also dove into the theory. And so sometimes it's hard for someone to talk about the the technical aspects of a technology, like here's how you do it, plus actually the theory. But in many ways, I think I can't think of a book that has got a more well-rounded, really summary of the ecosystem around Spark for machine learning. I haven't read one. So I think if people are interested in using Spark, Databricks, doing MLOps with those technologies, I think it's a very good read.
Thank you so much. Yeah, the goal was, when I start ideation of the book together with O'Reilly, it was around what can we bring to the table that will help people build their new systems, understanding that tools change or ecosystem change, yet a lot of the fundamentals are kind of staying the same. And so while the book is very technical, it speaks about ecosystem of tools and what is available for us to do kind of end-to-end machine learning. It was also very important for me to capture the conceptual pieces of architecture, of why these exist, how do we connect all the things, what is kind of like the underlying principles of these tools, in order for people to learn and also advance, if they need to advance to new ecosystem or new tools is coming up, they'll have it kind of set up in their mind, kind of a system thinking through, oh, I need so and so. These are kind of like the criteria. I know these tools give me that. What are the other tools gives me? So it kind of it helps us build better decision-making systems also when we are introducing new tools, and also give us a high-level understanding, the conceptual understanding of what does it take to build an end-to-end system with practical examples of the tools that we know that exist today, and definitely took over the industry. Spark is the most used generic analytics tool in the world. So a lot of people probably already either worked with it or someone in their office or in their work is using it in some constellation, which makes it very applicable for a lot of us to kind of tap into it and say, it's already here. Someone already spinning a cluster. It's already part of our production. What are the next thing that we can do with it? How can we take it to the next level and really build a machine learning system that we want to build, given existing tools
Yeah, I mean, it's a very good point. Like the, one of the analogies I've been trying to do a lot is talk about the car industry and the software industry because it feels very similar. One of the posts I did recently was I was talking about how when I was in high school, my friend had a 1969 Ford Mustang that was V8, and so this was maybe 20-year-old car at the time, and I just remember like, wow, this is, it can go really fast, and the tires are squealing. I remember he was always really poor though because he was just constantly burning gas. I mean, like when you accelerate, it's like five miles to the gallon, and then if you look at some of the changes in the industry, I mean, then they had the 1970s had the crisis for oil, so then cars got smaller, and then the cars started to shift to different like hybrid models, and then there's like electric models now, and like I have a BMW i3, which is kind of a interesting car because it has 120 miles of electric range, which is for most of the time is good enough for me, but it also has 2 gallons of gas to give it a little bit more, so it can go like another 100 miles, and so that's like a transitionary technology where you can kind of use the best of both worlds. And it seems like software in particular, this is happening all the time. Like you can't just abandon completely, one technology and say, okay, here's the future. Like as you point out, I think Spark is so pervasive that in 2023, you're probably going to encounter it. Now, in 5 years, how much will we use different technologies and how much, what percentage? That's a little more complex. But for today, I mean, Spark, if you're doing data engineering, you have to know it.
Yeah, it's for sure. And we see more and more cloud services also starting to integrate support with Spark. So definitely it's here to stay. It's everywhere with any, data engineer, data science, data analyst that I spoke with previous to writing the book as part of our research. It's like, what is the dominant tool platform that you already have in your in your stack, and they all had Spark. Well, some of them were struggling to figure out what it can do for them, right? How can they leverage the fact that it's already exists and there's already a DevOps team managing the cluster, and data engineering team that works with it. It was there, it was pervasive, it was highly used, highly supported and loved, um, and definitely a tool that we will see sticking around for many, many years. So,
Yeah, and the
then,
stuff that you're working on, which I think is very interesting, is also kind of an emerging solution on top of Spark, this Lake FS concept, which I don't know if that many people totally understand. I mean, I'm a little bit shaky on it myself. The concept, when you're talking to me a little bit, it made sense, but maybe that would be worth diving into a little bit about, what is it, and then what's the benefit of it, and why do people need it today?
yes. So one of the challenges that we see in the industry is it's very hard to manage our data. Our data changes all the time. In the past, we used to think that our data is immutable, and then we realized that our data is actually transient. It's mutable. It changes. We go back. We update it. Sometimes people ask us for different things that relates to our data. So many of us need to go back, update the features. As machine learning practitioners, as data scientists, we do a lot of feature engineering. So once we have the data set in one shape, it might mean that we need to kind of slice and dice. We need to enrich. We need to run another circle of feature engineering on top of it in order to produce something that is more tangible to train our machine learning model on. And so we create a lot of different versions of our data, which are deep copy that can be very expensive for us to create, very expensive for us to maintain, and very hard sometimes to collaborate because of the different systems that we leverage. For example, if we're using S3, If you looked into S3, their interface is not amazing. It works. Everyone are using it in the world. Everyone who use AWS are using it because it's kind of like the backbone. Everyone needs storage. Um, but then again, it's very hard because you need to always dig into these folders, essentially like a file system. You dig in and try to understand the URL where things exist, which bucket, how do you construct that bucket, what is a good data, what is not a good data, which version of the data should I use now. So a lot of challenges with that. So what we build an open source tool named Lake FS, kind of your Lake file system. If you think about it, that gives us a Git-like experience for our data lake. So we have repository, and you can go in and you can see actual like folders of your data, and you can manage the versions of your data in a shallow so it holds shallow pointers to your data. It's not deep copy, it's a shallow copy. So we can collaborate with other teammates, with other data scientists. We can roll back to previous versions, so we can revert to previous versions of the data, which is really critical for us as we're building machine learning models, because we always add feature, remove feature, filter things that didn't really convert the way we wanted to, and so on. So being able to revert to a previous commit of the data is critical. And another aspect that comes from productionizing machine learning is around reproducibility. If we work with FDA, if we work with governance, if we work with, ethical AI or trusted AI, we need to be able to reproduce the model in the same way that we created it to start with, because this is where we kind of show that this experiment is solid. We got the result. This is what got in. This is what we got out, get in, get out, kind of like in the machine learning space, which is really critical. And that involves both code, data, and our environment. And so for code, we have a lot of solutions. And I also speak about it in the book. How do you manage your whole machine learning lifecycle or experiment together with MLflow? Okay, how does it look like? How do I build it? What are the different pieces that are available to me out there? How MLflow server looks like? What are the different tables? How to look at it? What is the kind of the CLI that enables us to work with it, and so on. So that gives us a very good framework in order to save and manage the project, but it doesn't help us manage different versions of the data specifically. So it's kind of like they work really, really well together. And then all the way to deployment and so on. Sometimes I need to package some of the things. Sometimes I even need to expose some of the features in production as well, right? Because we have kind of our offline usage of our features, but then we need online usage of our features in production. So it enables us to expose that beyond as well. So it kind of like, and a very interesting tool that provided Git-like capabilities for data that builds on the concept of data version control as a core engine for people to take advantage of.
Yeah, I think that's a kind of a new area for many people when they're talking about machine learning. That the first days of machine learning for many people is they open up a Jupyter notebook and then they go to Kaggle and they run a project. They're like, great, I'm an expert. Then as you described, like the real world is really messy. And even in the scenario where best case scenario, I don't know, you're making like tons of different copies of the data, that's a mess and too expensive, right? And it does seem like the Lake FS concept is almost essential, really, to doing machine learning at scale, because like as you mentioned, how else could you even work with versions of data other than in this really error prone, expensive way? There needs to be, like as you mentioned, like a version control system similar to Git. Like I remember, believe it or not, back in the days when there were people that didn't use version control. Seriously, I've worked in companies where they didn't do it. I worked at a company one time where someone was just copying the files to the server, and it was they had spent hundreds of millions of dollars in this company. And I thought, what
Wow.
is this? Like, I mean, I'm approaching 50, so I've been around for a while. There was a time when there was some really bad things happening in the software industry, and similarly, like, I mean, why are we going to say the same thing with data? Like, wait, what are we doing? You're making all these manual copies of the data and throwing it all over the place and spending money and making mistakes versus more of like a uniform process where you're always making snapshots where you can have the production data, like as you mentioned, which is mutable because it has to be, but then you can make immutable version copies of the data and then always go back in time in case there's, like I think the good one that I can think of right off the top of my head is the self-driving car industry, you know, really is some trouble, in terms of there's a lot of controversy about it because there's pros and cons to different approaches. But if there's a scenario, for example, where a pedestrian who hasn't signed paperwork that says they're okay with being part of a beta test, is walking across the street and they get hit by an autonomous vehicle, that's actually probably going to be investigated. It hasn't, I think, happened yet, but it'll probably be investigated at a level where they would want to look at a versioned copy of the data and see what was going on. Right? Let's say what was the reasoning behind this particular model. And I could think of the doomsday scenario where someone's like, oh well, yeah, well, we can't do that. Like, well, that's a problem if there's a fatality associated with it. So there, I mean, that's kind of the dark part of it. But I mean, I don't know if you had any thoughts about the area of like legal responsibility in terms of the something like Lake FS.
Yeah, for sure. We see also some of our customers use it for FDA compliance because FDA is now saying your machine learning model needs to be explainable, needs to be reproducible, and to start building all this requirement. And this is a recent thing, right? It's from the last year or so that we're starting seeing those requirements from, you know, from the FDA, and probably there's other to come that say, you have to be able to explain what happened. We have to be able to look at the data so we can actually find the root cause and either fix it or at least know, from a legal standpoint, like what happened there so we can track it and we can improve that for future machine learning models. So as governance embrace the ability and kind of like the potential that machine learning brings to the world, where we can start automating a lot of the processes we're doing and kind of removing human error, because essentially when we are automating process, we are reducing the human errors that we know is often higher than machine error. We still need to be able to create that feedback loop, and kind of if things goes wrong, we have to go back and revisit what happened. So reproduce it, really look into the nitty gritty of all the details, and so on. And also, one of the things you mentioned really clicked. You said, how did we do it, till now? And I must say, a lot of people worked really, really hard in order to develop what we have today. And now we're kind of unlocking this new chapter in the machine learning space, and kind of embracing a lot of practices that are available for us in software engineering, like Git, right? This is a source version control. And now we're bringing it into the machine learning and data space, saying now we have a data version control. We learned, we know, we understand. A lot of great people build great tools where how about we'll leverage that for the MLOps space and build the tools in order to develop fantastic machine learning application, and really unlock the next chapter of our generation potentially.
Yeah, I feel like we're, MLOps is such an interesting space because I don't believe that there's like some perfect solution right now. That there's a lot of companies selling MLOps solutions, but as you mentioned, like you just brought up a killer use case, which is, well, wait a second, are you versioning your data? Right? Well, who's doing that? I'm sure there's people that are doing it, but like how many people are doing that, right? And then if you start to dig into other parts of it, like, well, how do you develop the model? Well, we use Jupyter notebooks. Oh, well, how do you test those? Oh, well, we just hope they work. Oh, okay, that's interesting. Like, well, how do you do a binary deploy? Well, oh, well, we don't do that. We don't need that. Really? Well, what if you like? I know that you're interested in TinyML. like I am, like why can't you fully automate, the deployment? That could be an interesting, next thing to discuss a little bit. Is like, I think you mentioned that you had, not in this particular session, but you had brought this up a little bit about the concept of building these testing tools that are Go based. That I think that would be a great thing to discuss a little bit if you have some time for that.
Yes, one of the challenges is around developing trust in the logic that we create, right? If it's machine learning or analytics or any type of processing that we do on top of data that kind of has the data source and kind of orchestrator. In the machine learning, we use different orchestrators. There's Kubeflow, there's Argo, there's no Kubeflow, Airflow, and so on. Sorry. We understand that we're building these building blocks at the end of the day. So it's not only about this one Jupyter notebook, it's actually we are sequencing a bunch of operations that end up being kind of a machine learning pipeline of the training phase. So we're doing all the training, the cleaning, the feature extraction, and so on. And then when we're happy with the result, we validate it, right? We do some validation. We're happy with the result. We're bringing it up to the staging environment where we can test it in an environment that feels and looks like production. So we can actually develop the trust that we need and kind of know that it's good, it has good accuracy, it's what it endures the all the challenging data drift, model drift, and so on that production might bring. And this is where it's very, very hard for us to do the testing, because during the development of the model itself, what we do, we use batch data, stale data. We took it out of the system. We either mirror production or we copied some data from production into an environment where we can do all these developments. We build this Jupyter notebooks. Great. We got some output. We dropped it into a package. We put it on Git, right, in our GitHub and somewhere. That's fantastic. And then in our staging environment, we have to be able to test it on fresh data, that it's still up to date, especially with data drift. It kind of change, means the way my data behaves in production can change. And so I want to be able to test it on data that is close to production as possible, even better if I can test it on production environment. But I am afraid of, testing things on production environments. It's scary. It means I can lose data, I can get bad results, and so on. And so being able to create isolated environment that mirrors or kind of do a shallow copy of my production data, so I can run those testing on real production data without harming my production data, is really valuable, because then I can develop that trust. I can develop the confidence in the system that I just created and see kind of an end-to-end how would it looks like in production without doing the heavy copying or mirroring of the data. And there's also PII aspect to it, because if I'm doing a deep copy of my production data, or especially some data scientists will download production data to their machines, that can be a problem in terms of legal, right? Because someone needs to track it, someone needs to delete it, someone needs to make sure there are permissions to actually take a look into this data. And having that system in place that enables us to create isolated environment for staging or even for developments, if we're working with PII, is really, really critical, because then we have one person who controls the policies around the data. No one is downloading data to their laptops anymore. So we are controlling the PII aspects, and we also enabling people to run this whole operations on a large scale of data so they can get a more accurate result and hopefully more statistically significant result as well, because they're running on actual real data that comes into the system. So this is one aspect of it. And I think another aspect is related to testing. And like you mentioned, if I have my Jupyter notebook and this is what produced my code, how do I do unit testing? How do I do end-to-end testing? Integration testing. It's like a
How do
whole
you
new
even
world of
how do you even lint your code? How do you even make sure that it essentially compiles? You have so somebody could give you a Jupyter notebook and it could have bugs because they built a model with it and then accidentally changed something because someone interrupted them. They're like tapped them on the shoulder, and then they have a bunch of like non-executable code, and then they checked it in. And with Python, there's no way. You have no, I mean, there's no there's no concept of compiled code.
Yeah, someone changed something in the environment, and it stopped working. It's a very interesting aspect and very interesting topic that as an industry we will have to start solving in order to streamline the whole work around machine learning. Everyone wants to do machine learning. Everyone wants understand that there is untapped potential for the business, right? Because it's also being driven from a business side. And there's a huge potential and kind of a business goal that we want to drive. We're doing tailor-made solutions, autonomous driving, and so on. Yet we still there's like the nitty-gritty parts of technicalities, like, oh, how do I actually test it?
Yeah,
Which
I
are very,
think I
very
think
interesting.
you raised a bunch of really good points about the idea of, the risk if of downloading the data to your laptop. It's not theoretical. I mean, there's so many hacks that have happened. It's almost, you can bet on it that there's going to be some data breach with, PII, released somewhere. So that if you almost assume that that's going to happen, you eventually want to make it so it's not possible to move the data. And that's a very interesting use case for the Lake FS. And then also the idea of, which is really classic DevOps, which, or classic systems administration, is that you have to have environments that are identical or almost identical, so that you reduce errors and you don't want humans going through and making mistakes. I mean, that's a classic. In the 90s, I remember people were doing, systems administration where they were trying to make things fully automated. So I think that's a big, you know hole, I think, in MLOps right now that needs to be addressed. And it is very interesting that's one of the things you're bringing up. The other one I think that is a big hole in MLOps, as you mentioned, is the Jupyter workflow, which on one hand, obviously it's a useful tool. I mean, it's great to be able to chart things and, use little quick experiments. But I think one of the things that's kind of fascinating, is that I've been thinking about this for the last few weeks or so, is that there was like a transition with technology where, first there's C, and people are like, wow, this is amazing, look how fast it is. And, people are programming C, and it's like, wow, you have to really be like a genius to be like a C programmer. I mean, you have to be really, really smart. And then C++, and then people built these higher level languages like Python, and obviously wildly successful, and the number one programming language of the world, because readability was the new thing. And then now we start to look at maybe 2010 and beyond, and all of a sudden there's Go, right? And then there's Swift, and then there's Rust, and there's these other languages. Like, well, actually, what if we don't just go performance or readability, we go in the middle? And what is interesting about these new tools, like the LLM based tools like Copilot, is that what I think is going to happen is that some of these newer languages are going to be more adopted, because people realize, like, wait, I think I just read something that said 60% of Java code that's being written in Visual Studio Code with Copilot enabled is written by Copilot. And that's just not even within a year. So, these compiled languages, which are much safer and much more performant, it does seem like that will take a hold of some of the problems with someone going, well, Python's so easy. So it's going to be very interesting the next 5 years in particular. There could be like a shift of where was the Wild West, where you copy data, you use scripting languages, you just do all kinds of wild stuff, Jupyter notebooks, and now what could happen is that there's still like a rigor, like maybe more compiled languages, more data versioning, more like reproducibility, in some sense, I think it's going to be very exciting to see what happens.
Yeah, it's always interesting to look at the performance versus readability of things. And also, like you mentioned, the LLM tools that are now available for us to take advantage. I always say it's much faster to review something that already exists and kind of fix the little things than write it from scratch. And so you mentioned Java with 60%. This is an amazing metric, and also speaks a lot to how Java is built and how, there's a lot of boilerplates within Java. It's you write something, you have to write another 5 classes just to support this one thing, and with Copilot and other tools now, it's you can trust them. They put something together. You can review it at the end of the day, right? You still need this domain expertise to understand that the system connects well. But now you're more of kind of like the architect of the system, the architect of the code. That's different tools, automated or humans, created these different snippets and now you're putting them together to make sure everything really sticks and gives you the result that you're looking for, which is very, very interesting. I will say all these amazing tools were trained on large scale data. So I know there is in the industry, there was a big conversation around, do we really need to train machine learning models on a large scale of data, or do we just need good data? And then the question is, what would be a good data that is significant enough in order to produce highly significant, highly accurate model? And then we see all these streams of new tools like Copilot, ChatGPT, that just, they were just saying, instead of trying to find significant data and kind of build the whole statistical models around extracting significant data out of my data set so I can train it on a smaller scale of data, how about we'll just train it, we'll use scalable machine learning and train it with tools that has distributed engines. And it's an easier problem to solve, still hard, but easier problem to solve than trying to find significant data and hope to build a good model. So all in all, very, very interesting generative AI world that we're tapping into.
Yeah, I find it interesting that, like you mentioned, you start with machine learning, and we now have these tools that, in my opinion, I probably am 5 or 10 times more productive with Copilot. That, but then what do I write? I write MLOps code. So I write machine learning code. So you have machine learning that helps me write machine learning. So then there's this feedback loop, right? Where then the more people that use these tools will in theory might write more libraries, write more systems that, and the human brain is often not great at understanding exponential growth. I'm curious how quick the world's going to change. I think very quick, because of the fact that we're able to use AI to create AI.
Yeah, I say my opinion here is the domain expertise is critical. We'll still need to know how to build this code. We still need to know how the puzzle connects, conceptually and also practically when looking at the system itself. And while I have all the snippets that some people can go into Stack Overflow and just copy them, also is right. It's not that far away from that. It's still easier to converse with a chat. Sometimes it produce it for me or have it built in within my IDE to kind of take advantage of it right away. Yet expertise here is key. So while I'm using my machine learning to build my machine learning model, I still need to understand what it is that I'm doing, right? What are the different pieces that I'm putting together? And so conceptual system understanding is going to play a critical role in the future, and also make us much more productive, but also puts a lot of demand on anyone that's building these to kind of really understand from an understanding point of view, not necessarily kind of hands-on practices specifically, but an understanding point of view, like how it behaves. So when there is an error and problems will occur, and they're occurring today and they will continue to occur even with automated systems, we will be able to go back and debug and really find a the needle in the haystack to fix the bug or what happened in the system.
Yeah, I agree with you. I mean, I think it's like garbage in, garbage out, where if you don't know how to think in terms of distributed systems, then how could you possibly build a distributed system even with like Copilot? But on the flip side, for the expert, as you mentioned, I think it's just a multiplier, right? Because now you can actually build more things simultaneously, and the boilerplate code, like you mentioned, just goes away. Uh, and in some ways, I think it's going to make the experts actually much, much more valuable. So it could actually have like unintended or surprise, not unintended, but like a surprising effect where people say, "Oh, it's going to make developers cheaper." Well, or it's going to make very good developers much, much more expensive because just like the laptop with the cloud, it's similar. Like I remember when we used to have to build things in a data center, and that was what everybody did, and then the cloud was this like thing that, oh, it's so evil, don't use the cloud, or it's too new or whatever. And then people with a laptop built entire companies. Like a person would just they would just there was like a 20-person team that would get out coded by someone with a laptop. Now we have the laptop because you can build cloud, and now we have Copilot. So if you're have deep expertise, I mean, what could you build? I think almost anything.
Yeah, almost anything. It's amazing. It's I've seen some people, there's I don't remember exactly, but I've seen some YouTubers are now saying, I can learn it and come join me as I learn how to code together with ChatGPT or Copilot. And it's really interesting to see what's the prompt, how they access it, how they build their new code and their new system based on that. Now they have kind of an automated friend sitting next to them and helping them write faster. Um, and it's really interesting what you mentioned. Well, I always look at machine learning is, well, so there are different schools of thought. Some people say, oh, it's going to take over my job and I'll have nothing left and so on. Um, Yet I think it's actually the other way around. It's how can we leverage that, knowing that now I can be more productive, now I can do more, and tap into my creative side and look into the application and say, now that I have all this amazing power that in the past, I needed like 2 years to build such a system, with automation, I can do it within 2 months. What more can I do now that things are much faster? Um, and turnaround is much faster, and I can actually see and deploy my system and kind of get it into the hands of real users faster. That I think is going to change a lot of the way we work today and a lot of the different applications that we're using. So I definitely look forward to see everything that comes out of generative AI and how it can untap into people's potential. Because many times we just get caught into kind of the operations, kind of doing the same thing over and over again, and we don't always tap into our creative side and our true potential. Um, and now, when we are more productive with these tools, a lot of interesting things can happen.
Yeah, I can't agree more. I've actually, it's like you stole the thoughts in my head out. That a lot of times it's easy to think about, oh, you're going to steal my job and all this, but my entire life I've basically been involved in automation, and it never is the case. What happens is you were working on things that were really horrible, and now you don't have to do those anymore. Like, I remember compiling Linux and getting stuff installed back in the 90s, where it would take me a week. I mean, literally a week to compile Linux. Oh, this is broken. Oh, let me get Apache working. Oh, wait, how does Apache work? Like, what's the config file format? Oh, and you're just like, this is awful to build a website. And then you have to set up DNS. Like, you have to set all this stuff up, like your own DNS server, then wait for like it to fully like be alive and all this stuff. And then now you just go to Docker and you just put a file in that says like, Ubuntu, and you can create 1,000, web services. So it just makes it so that you can do more things. So I totally agree with you. I think it's going to be that the boilerplate, icky things that we were dealing with, like, XML files and some of these like really things that are not fun to look at just go away, and then you just have more time to build incredible things.
Yeah, it kind of reminds me a little bit of the different generation in tech. I don't know if you got to notice that, but there's always someone that's like the architect, super senior in the team, and it's educating all the juniors or the newcomers into the company, like how the system works, how to automate, how to do all these kind of things. And I always noticed that they were never worried about, if this new person who just came in is going to replace them, because what they've seen throughout the years, and similar to what you experience, it's like this cycle of there's always going to be more things to do, there's always going to be something new, there's always going to be more creative ways and more capabilities to build. And this is kind of like a similar thing, only on a much larger scale. So anyone today who sits at home without sometimes having access to these experts to work with can leverage these tools to start learning and building a system that a year ago they weren't necessarily able to do that because they didn't have this senior person on their team sitting next to them and mentoring them or doing a code review for them to learn from. So that's really significant, and it will enable a lot of people to work in tech, in my opinion, and we'll see more positions that are around these kind of like experiences and skills for sure. It's very interesting. I look forward, like 10 years from now, what will we have? What will we see? Will we have better machine learning? Will we have better data? Will we have better tools, IDEs? Like, where are we heading?
Yeah, it's interesting. You got me thinking a little bit about even some other trends, like with recently I noticed that there was a report that said that 60% of people that are developers didn't get a computer science degree. So there used to be this theory that all people that are programmers have to get a computer science degree, and then they would restrict, right, the number of people that could get a computer science degree. I met people that were just brilliant that tried to get into Berkeley and get a degree, and they couldn't. They were like not allowed. They were only allowed to take math, or they're only some other subject. And it's my kind of sad. I mean, that people really have a passion for they want to learn IT or software development, and then there was like this artificial gate, and then the other part for that I experienced when I was learning to program was there was no source of information for programming, so you had to find someone who was an expert. And a lot of times the early people I encountered were not necessarily like super like friendly, like helpful people. Like a little bit of curmudgeons, and we're like, why are you asking me this? Like, I can't believe you don't know this. And like for a lot of my early days, I just felt stupid. Like every day, like someone's just berating me and telling me like God, I can't believe you didn't know this, and like, and then now, like as you mentioned, you can just go to ChatGPT and you can say, hey, I'd like you to explain how I can embed an Onyx model inside of a Rust command line tool. I'm having a problem. Where if you put that on a message board, or even maybe even Stack Overflow, I don't know, like because I think they have a bad reputation sometimes they have a bad reputation. Someone could say, I can't believe you don't know how to put Onyx in Rust. That's an outrage, right? Even though it's super complicated and almost no one's doing it. And then you go to Chat GPT, and Chat GPT goes, oh yeah, just use this macro. Boom, there we go. Like, so it could, I think one of the other issues that would be very interesting is that legitimately there has been a imbalance with diversity in tech in particular, and it would be very interesting to see if this plays part of a role where basically anybody that wants to be involved in tech, it doesn't matter who you are, you can actually ask somebody who's not going to judge you and going to be helpful.
Yeah, it's definitely, and it's very interesting. And this is where I'm saying, like, understanding the concept, like even knowing what to ask, right? Asking ChatGPT to write me that embedded code or Rust code to embed my model within a CLI. I still need to know what to search for. And
Mhm.
I think this is where, all the different content that people are producing and kind of creating awareness and all the books and courses are still valid. So kind of people can find the thread to know what to start looking for, um, is really, really critical. Because if I don't know what I don't know, right? ChatGPT won't let me know how to do it because I need to be able to build that prompt in order to start even thinking and these terms. Um, so AI definitely, I agree with you. It enables a lot of people. It creates more inclusive environments where we can learn from a robot essentially that is more friendly, sometimes opinionated, being fully honest, sometimes opinionated, and we need to use our own understanding of the space to decide if it actually makes sense or not. Like if we can trust some of the information there, because it also it does expose some mistakes sometimes because of the how it was built, um, and and still be curious around consuming content and courses and books around this topic so we will know what to start looking for. I think that's a critical aspect.
Yeah, I mean, I agree with you. I think the knowing the right questions to ask comes from reading, right? Or, trying something out. And there's no substitute for just failing, right? Like you try something, it doesn't work. Try something, it doesn't work. It's a very good point. I mean, I guess speaking of that, maybe another topic that we could discuss is something you were really interested in, and I'm interested in, is this tiny ML concept. Like what is your interest in this, and what are the things that you're thinking about doing?
So I was thinking mostly on the application side because we can train. So it's one thing to train a machine learning model, and that's the other thing. How do you embed it into an applicative side of things? Right? You can train it on a large set of data. You get good accurate model, or you get whatever model that you were looking for with some significance, and then the model itself can be either big as well, or it can be tiny in terms of footprint and memory, and then you can embed it into other systems. And it kind of opens the door to how can we automate different things that we do. Like autonomous driving is one of them, right? There's a machine learning model embedded in a car, um, that communicates with the cloud, depends on the architecture, but it does communicate with the cloud, exchange information, and so on. But then in order to be able to deploy it into smaller IoT things, we need to have a smaller footprint of the model as well. This is more like the engineering side or electrical engineering side. Like, how do we bring it to a small scale that still it can still do the things that we expect it to do? It can still make predictions and decisions. Um, Yet, it fits within my tiny IoT. So I think it's an engineering problem that as an industry we'll have to think what will be the right algorithms in order to take the model that already kind of generifies the world, right? It makes decisions based on a set of rules and kind of even distill these rules down a bit more, saying we're either agreeing to a higher rate of error or we know how to save it in a way that it's more compressed. Um, Different angles about this world. I know it's still an evolving one, and I'm curious, what's the applicative side, right? So what's the motivation from a business side of view for a data scientist and so on, and also what the technology can do now that we know, this is something that we want as an industry.
Yeah, I think I think it's a very interesting area, and I taught a class that did edge-based machine learning for a few years, and it definitely opened my eyes up to the fact that it is a viable space, and that in particular you could think about almost any electronic device could have machine learning in it. Now it could just be like a thing. You always have some kind of machine learning. But what it does is, to your point, like one of the engineering challenges and this is why I've kind of shifted a little bit of abandoning scripting languages, is that it does seem like performance does matter for edge, and in particular the deployment matters as well. So like if you can deploy a binary that's tiny, like I've been playing around with some Rust machine learning binaries where they're like 10 megabytes, or you could put like a really tiny model inside of a binary, and you could build it into a command line tool. So you can, as you mentioned before, like you can test out some kind of thing you're doing, maybe like a really simple computer vision prediction. But if you don't have to do anything different at all, but it like compiles to this other target, and it can go on to Raspberry Pi, or it can go on to ARM, or whatever it needs to go to, that's a pretty compelling story. And I see the compiled um, tiny ML space really being very interesting in 2023. I think there could be so many use cases. Like there was a project I was working on with a Duke student where they were identifying endangered species through like a portable camera. That's a perfect example of like an edge case, right? Is that you train a model, you put it onto a device where it can detect certain endangered species, and then you could put that low power device somewhere where it could run for, I don't know, like 6 months or something before you change the battery, and you could have a huge impact on preservation of some endangered species, where if you couldn't put it onto that device, there's just no way to do it.
Yeah, that's really interesting, especially in environments where you don't necessarily have connection to a server, right? It's kind of like its own box. It's airtight sealed. There's no capabilities to communicate with a server that is deployed somewhere in the cloud, someone else's machine, or on-prem, and you have to have everything concealed within this one small thing that captures data, analyze, run it through the model, do some prediction or take actions based on it. And I think I've seen it in sometimes you'll have like this submarines that are more for research. So there's no humans on board. It's all machinery, and then it has to make decisions sometimes without even connection to external world, to cloud, or to a dedicated server, and everything is still tied within that. It's very very interesting. Um, yeah.
Cool. Well, I mean, we covered a lot of topics, I think, that are very interesting topics that hopefully were enjoyable to people. And I would say the maybe in summary on my end, that I really, I try not to say things that are false. I really did enjoy your book, and I think it's a great book for someone to understand the ecosystem around Spark and why it's so important. And if you have a chance to read it, I definitely would recommend it. And appreciate the time you spent to talk to me, and it really learned a lot actually from a lot of your ideas just in the last hour. So really appreciate your time.
Likewise, thank you so much for bringing me on. And yeah, if anyone is interested, copy or all will be available on either O'Reilly or Amazon. You can grab one. And I want to thank you and everyone in our industry that really did the great work reviewing, providing suggestion. Also, everyone that were part of the research. When I started it really takes a village to write a high quality, good book that gives people both practices and kind of conceptual understanding of the ecosystem. So thank you.
All right. Talk to you
All
later.
right.
Okay.
Talk later.
Bye.
Bye.